So we've got hexanoic acid, this thing here, which is obviously an alcohol because it's got an hydroxyl group. This thing here has got a double bond, so we're thinking it's an alkene. This has got a bromine and a double bonded O, so that's interesting. This dude here has only got an O and it's on the end, so it's an aldehyde. And this dude here we need to draw out to see, but it is definitely one of the alkanes, alkynes. Okay, now it says the letters A to F in the table below represent 6 organic compounds. So what I did now, just by reading through this is what I want you guys to do during your 10 minutes of reading time. I want you, obviously you can't write it down, but I want you to read through it and identify in your head what is going on, and read through these questions, because then when the exam time actually starts, most of you will have probably answered most of these questions before you even actually start writing the paper, and that's pretty awesome because that means you've gained a whole bunch of time for the other questions that might be a little bit more tricky. Now it says, use the information in the table where applicable to answer questions that follow. Write down only the letter that represents a compound that A, and it also says a compound may be used more than once or not at all. They want something that is an unsaturated compound. So saturated something is with something that is single bonded. So an unsaturated is going to be this guy, which is obviously letter C. 2.1.2 has an hydroxyl group as a functional group. There you go. That's B, our alcohol. Now it says write down the IUPAC name of compound C. Okay, so we've got double bonded over there, which we actually have to go through that double bond because it is the part of the functional group. Now we need to count. We got 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so the longest arm is going to be 5. So we might as well count from the left because we always count closer to the functional group unless it's just branches. So it's going to be 1, 2, 3, 4, and 5. So 5 is pent. Do we agree? Pent, and the double bond means it's pentene, and we're finding it on carbon 2. Okay, so you're either going to write pent2ene or you're going to write 2-pentene. I don't mind which you prefer. Then you can see that there is a methyl group here and a methyl group here. So we need to tell them where the methyl groups are. So it's going to be 2, 3 dimethyl. And a lot of my students ask, why do we have to write di if we write 2, 3 methyl? Because guys, okay, because if you write 2, 3 just methyl, then they don't know whether to put the methyl group on the 2 or the 3, okay? So that's why you write 2, 3 dimethyl 2-pentene. Okay, so that's that one done. Now they want the IUPAC name of compound D. Okay, so do you agree that D is interesting because it's got a bromine here, but it's also got a double bonded O, which is not at the end, it's at, so therefore this is definitely something with an anal on it, okay? It's a ketone. This is a ketone with a bromine on it, okay? And it's got a methyl group. Right, so let's first count the longest chain. So it's going to be 1, 2, 3, 4, 5, 6, 7. So the 7 is going to be hept, and because it's a ketone, it's going to be heptanal. So it's going to be heptanal. But we need to tell them where we find in the double bonded O. So it's going to be 2-heptanal. Then what do we do? Now we need to realize we're counting 1, 2, 3, 4, 5, 6, 7. Now do you agree that this is a bromo and this is a methyl group? And whenever you are labeling your groups in front of your original proper name for your molecule, you need to go alphabetical, not numerical, alphabetical. So even though this is on 6 and this is on 5, we do number 6 first. So we go 6 bromo, then we go comma, 5 methyl, and then 2 heptanyl. I apologize for being all squished up. Okay, so it's 6 bromo, 5 methyl, 2 heptanyl. Then it asks you for the structural formula of compound F, which is great because the only way I'm going to know what's going on here is if I draw it out. So I'm going to start on the right hand side because we know that carbon's got 4 arms and 3 of them are taken up with hydrogen. So we've got 1, 2, 3. Then we've got, that's those 2. 1 arm left for a carbon, that's there. And then we've got another carbon and a hydrogen. So I'm thinking this has to be a triple bond. So there needs to be a triple bond between this carbon and that carbon. Okay, so that's awesome. So there's your structural formula of compound F. Now it says consider the terms isomers. Which compound in the table is a functional isomer of ethyl butanate? So ethyl butanoate, if we think about it, ethyl's got 2 carbons and then it's got a butanoate. So remember that this is a what? It's an ester. So how do esters work? It is going to be an O, then C, and there's 4 of them. So it's going to be double bonded O, and then it's 1, 2, 3, 4, and the rest is hydrogens. So do you agree with 1, 2, 3, 4, 5, 6 carbons, and we've got 2 oxygens, and the rest are hydrogens. So let's see here if there's anything here that's got 6 carbons, 2 oxygens, and basically a whole bunch of hydrogens. And the only one here that I can see, oh, it's going to have to be hexanoic acid, because hexanoic acid is 6 carbons, there's the hex, and the oic acid tells you it's a carboxylic acid, and the carboxylic acid functional group is COOH. There you go. So it's got 6 carbons, 2 oxygens, a whole bunch of hydrogens. So the correct answer for that is A. Now it says draw the structural formula of a chain isomer of compound E. Okay, a chain isomer just means really that you need to place that O somewhere else. So instead of it being on the end, we can put it anywhere else. So we could go CH3, except they want the structural formula. So therefore we got C, 1, 2, 3, 2. How many carbons are there in this? 1, 2, 3, 4. Okay, 2, 3, 4. Let's put the double bonded over here, and then the rest. 1, 2, 3, 4, that's fine, and there you go. And then obviously your little hydrogens everywhere, and guys, you cannot leave out your hydrogens. You leave out your hydrogens, you are going to get it wrong. So there you go, there is a chain isomer of compound E. All it's done is moved your oxygen onto somewhere in the chain, so you've changed it from an aldehyde to a ketone. Now it says draw the structural formula for the organic compound formed when compounds A and B react in the presence of sulfuric acid. So I'm going to erase this because I need the space. So we're adding hexanoic acid to an alcohol. So when you have a COO, a carboxylic acid, and an alcohol mixed up, we get an ester plus water. Okay, so this alcohol's got 1, 2, 3, so that is going to be propanol, right? So they want us to draw the structural formula for the compound that's formed. So this bit here is propanol, and this is hexanoic acid. So what are we going to end up with? We're going to end up with propyl hexanoate. That's how it joins. So prop is 3, so it's going to be C, C, C. They join it with the oxygen. Then it's C double bonded O, and what's this got? 6 carbons. 1, 2, that's 3, 4, 5, 6. Oopsie. And then everywhere here is going to be hydrogens. And guys, I'm not writing in all the hydrogens. You guys have to write them in.